Hello everyone, welcome to lecture number 3 of the 6th week. In this lecture, we will explore some formula of differentiation. As in the last lecture, we had explored the chain rule as well as the explicit function and implicit function and how to find out the differentiability of the explicit and implicit functions. Here, some of the formula which are going to be useful for you, and you have to remember those formula. Otherwise, it will take more and more time consuming things. That's why for finding out the differentiability or derivative of the complex functions, you remember some of the easiest formula as well, right? So, a simple formula for differentiation. So, in the table below, u equal to fx and v equal to gx represent differentiable function of x, and since it is not given where it is differentiable, that means we are considering any point, arbitrary point x in the real line, right? And also remember this one, we are all talking about the real valued differentiation of the real valued functions, not the complex valued function. The complex valued function and their differentiability is not included in your course. It is only for the real valued functions, right? So, take u equal to fx and v equal to gx, and suppose that both these functions u and v are differentiable function for independent variable with respect to the independent variable x, right? So, what will be the derivative of a constant function? I will explore for you so that you can grasp that it is not the only formula, but we can explore very easily. So, as you remember that a derivative of a function fx is equal to nothing but the existence finite value of this value, right, c, or I can change this one a here, and this will be fx minus f of a divided by x minus a, right? That's what we have done, and we have to take at x equal to a. So, this is equal to limit of x tends to a, f of x is a constant function. That means we have here domain and here ranges or codomain, and this is the function f. So, x is here fx, x1 is something this one, but both these functions are constant function. So, everything is going to be the single value. Range consists of some single value c, right? That is quite easy. So, what will be the value of fx? Fx is c. See here, this is the c, right? Minus, what will be the value of fa? Let us say a is here. So, it is also going to be the range c. So, this is c divided by x minus of a. So, this will going to be limit x tends to a, 0 divided by x minus a equal to 0. And look at the structure. We have taken this c as any arbitrary constant or real value. That is why for each constant function, the derivative of that constant function with respect to its independent variable is always 0. Remember this one, and this is written here without any reservations here. We can always state that the derivative of a constant function with respect to the independent variables is always 0, right? Similarly, derivative of a constant multiplication of a derivable function. So, we are here c as a constant here, c as a constant function, and u is given, u is f of x, which is differentiable function. So, this is nothing but you can take out c from the derivative, outside of the derivative, that means c into a derivative of u divided by dx, right? So, we can use this one as a c u dash is nothing but c into u dash, right? C taken as a constant. Similarly, derivative of sum or difference is nothing but its individual sum or difference of the derivative. Product rule, we had seen that derivative of uv is equal to one time you have to take the one dependent variable as a constant, and then take the another one as a derivative, and then plus of take the another as a constant and take the first one as the derivative. So u dv into v dx. So it can be written as u v dash plus of v into u dash, right? Similarly, the quotient rule, as we have seen here, derivative of u by quotient uv is equal to v into u dash minus of u into v dash divided by v square. That will be the one formula. You have to remember this quotient and product. And then the chain rule, we have seen that you can include various variables in between or intermediate between this x, right? So now use this one. What will be the derivative of xp power n? Xp power n has the derivative n into xp power n minus 1. Similarly, what will be the derivative of un? N into un minus 1 into du dx, right? See here. Since the x, the function is x has the same independent variable, that's why it's written. But u of n d of dx is equal to n into un minus 1 into du dx, right? Similarly, derivative of ap power x is equal to ln a first into ax. Remember this one. So, and similarly, what will be the differentiability of a into u? So, ln a as a constant into au into du dx. So, here we have done this, right. So, this is the always true. Similarly, we have exponential x. So, the derivative of the exponential x is equal to exponential x. What will be the derivative of exponential u, where u is a function, derivable function, differentiable function. So, now you have to take exponential u into du dx. So, that is quite easy. Both sides I am giving you one side as directly involving the explicit function, and in the next side we are giving you the implicit functions. So, what will be the derivative of log of ax? Here base is a and exponent is x. So, this will give you 1 divided by ln into x, right, or you can use the log x. And what will be the log e into u? So, log u. So, this is log x, this is the log u. So, this will be also giving you the constant as 1 divided by ln a into u into du dx, right. And what is the differentiability of or derivative of ln x? Ln x means natural logarithm. Here ln x means natural logarithm, right. And log of a, that means the base is a, not the e. Here base is e. So, ln u, what will be the differentiability or derivative of ln u? That is equal to 1 u du dx, right. Similarly, what will be the derivative of sin x? That is equal to cos x, and then cos x. Cos x is equal to minus sin x, tan x equal to sec square x. But what will be the derivative of a sin u, where u is also a function of x itself? So, you have to use the which one? You have to use the chain rule. So, let me show you here, d of dx is sin of u. Now, think about this trigonometrical function. This trigonometrical function does not involve explicitly x, but it involves u. So, firstly I have to take d of sin of u divided by d of u, and then I will take du by dx. So, the first term will give you cos of u, and then this will be du dx. That is the chain rule. So, as you can see here, the right hand side, the whole of the things using the chain rule, as u as a function of x. But here there is no need to use the chain rule, it's the formula we have to use, right. Similarly, Same thing is here. All those right hand side using the chain rule, and this one has the direct formula. So derivative of a cot x equal to minus of cos x square x, derivative of sec x is equal to sec x into tan x, and derivative of cosec x is equal to minus cos x into cot x. Derivative of a sin inverse x is equal to 1 by a square root of 1 minus x square, right? Remember this one, this is quite easy. So derivative of a sin inverse x can be also written as arc of sin of x, ARC, is equal to 1 by a square root of 1 minus x square. Derivative of a tan inverse x is equal to 1 plus x square. And similarly, as you can see here, derivative of a sin inverse u, where u is a function, using the chain rule, you will find out, I will show you here, d of dx of sin inverse u, that can be written as d into sin inverse u divided by d of u into d of u by d of x. This will be nothing, but as the argument are the same, so 1 by a square root of 1 minus u square into du by dx. That's all, right? Similarly, you can find out for tan inverse x and so on. So the first example is fx equal to x 6x cube minus 9x plus 4 with respect to x. Find out the differentiability of fx, right? Here, as you can see, there is no need to do anything. It's a explicit function, y equal to is given. So f of x is given here, 6x cube minus 9x plus 4. Use the sum of the differentiability of the two functions, right? So that will give you individual differentiability. So f dash of x is equal to 6 of x cube differentiability minus 9 of x differentiability plus 4 differentiability. So this will give you 18 of x square minus of 9, and this is going to be 0. This is the constant function. So this is going to be 0, and this means we have 18x square minus 9. It is also written 9 into 2x square minus 1. This is your answer, right? Now, look at, for example, 2, x into sine inverse, x power sine x, where x is greater than 0, and find the derivative of such function with respect to x. This is a good question, and you will see that how the mathematics involve in finding out the chain rule as well as the implicit functions form. You cannot write down y equal to something. You have to write down y equal to x sine 1x, and it cannot be evaluated y equal to some explicit function. No, you cannot. So it's an implicit function, and we are going to use what? We are going to use differentiation for both sides first. Then if we required, then use the chain rule whenever it is required, and then finding out the final answer by simplifying the whole equations or criteria. So let y equal to sine x, x power sine of x, right? Since it is in the power, therefore I have to take both sides logarithm of this. Once we are taking logarithm, then it will gives you sine x as a main product or the quantity of this, the scalar quantity of this one, right? So log of y can be written as, so I am writing for you, so x power sine of x. So therefore taking log means you can take the logarithm as well, but anyway, since it is written log, but let me advise you, but you have to write ln. So ln y is equal to ln x sine of x, right? This is out by taking logarithm both sides, right? Now this can be written as ln x into this sine of x. So we have here, finally we have ln y is equal to sine of x into ln of x. That is what we have, our equations. our given problem. Now I have to take differentiation both sides. So taking differentiation, taking both sides differentiation with respect to what? With respect to x. So ln y can be written as 1 by y into dy by dx is equal to, here there are two terms sine. Okay, so I'm going to change my color here first. Here, so this is sin x and the ln x. There are the two terms. So we are going to use the product of the two functions, derivative of the product of the two functions. And I believe that you have remembered this one as u v dash can be written as u into v dash plus of v into u dash, right? We had already seen this one. So here we are going to use the same thing. So this one will be a sine of x into ln of x, derivative with respect to x plus sine of x dash into ln of x. So here sine of x into ln x, that means 1 by x, plus sine x dash, that means cos of x into ln of x, right? Now simplify the whole things. That means take this 1 by this side. You will find out dy by dx. Dy by dx is what? Y into sine x by x plus of ln x, right? Into cos of x. So I can write this one y into sine of x by x in plus ln x into cos of x. This can be written as y, that is y is equal to what? We have already assumed y equal to x sin x, y equal to x sin x, y equal to x sin x, and this is equal to sin x by x plus of ln x into cos of x. That will be your answer, where you will find out dy by dx, right? This is dy by dx, this is dy by dx, and that is what your answer is. Similarly, find dy by dx if x equal to a theta and y equal to a sin theta. This is also good question, and you have to find out firstly in dy by d theta and dx by d theta in terms of theta and x, and then put the given value. So since we have to find out dy by dx, dy by dx can be written as dy by d theta into d theta by dx, right? You can find out this. So this can be written as dy by d theta divided by d of x by d theta. This is the same thing I am writing down. So now find out dy by d theta and dx by d theta. Here y equal to a sin theta is given. So dy by d theta is equal to a into cos of theta. And here x equal to a cos theta is given. So dx by d theta is equal to minus of a sin of theta. Now put this value, a cos of theta divided by a minus of a sin of theta. A cancel out, and this will be giving you minus of cot of theta, right? So that's what your answer is. Now the example 4, find dy dx if x power, the, as you can see, indices, these are the indices which is fractional one, x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. Now, can you write y equal to something? No, you cannot write down this one. You cannot have from here y equal to some of this. I mean, if you are finding out, or if you are able to find out, then it will be going to be a very complex structure which is intractable in a mathematical manner. So that's why we have to do some of the theorems. That means for implicit functions, we are going to use firstly take the differentiation both sides, then if it requires you simplified it, if further required you use the chain rule, and then put the whole value finally to find out the dy by dx. So let x equal to a cos theta and y equal to a sin q theta. Now you can raise the question that why you are choosing a cos q theta and why a sin q theta. There is some intuition where the indices is 2 by 3 and 2 by 3, you have to understand that if I take q, then theta and theta will be cancelled out, and since 2 by 3, that means that will give me a square and a square, and we knew that sine square theta plus of cos square theta is nothing but 1, right? So that is the intuition and that is the trick to find out which x equal to a will work for me. So here x p power 2 by 3 plus y p power 2 by 3 is equal to a p power 2 by 3. If I put x equal to a cos q theta and y equal to a sin q theta, right? So x p power 2 by 3 is what? Plus of y to p power 3 is equal to what? This will gives you a p power 2 by 3 into of cos square theta plus of sin square theta, and this will comes out to be a p power 2 by 3, right? So that means x equal to particular value a cos q theta plus y equal to a sin q theta will work, and that means I can use this parametric equation. This is called a parametric equation, and we can find out the value by putting dy by dx. dy by dx is nothing but dy by d theta divided by d of x by d theta, and dy by d theta you can easily find out from here, y equal to a sin q theta. So dy by d theta equal to what? dy by d theta is equal to a into 3 of sin square theta cos theta, right, into cos of theta. So doing the same thing, dy by d theta equal to 3a sin square theta cos theta. Similarly, minus of 3a cos square theta sin theta. Now I can write here x equal to a cos of q theta. So dx by d theta is nothing but since it is a q1, so this is minus 3 cos square theta into sin of theta, right? So doing the same thing, this will give you 3a sin square theta cos of theta divided by minus of 3a cos square theta into sin of theta. 3a is cancel out, and you will find out cos theta square is cancel out, sin theta sin is cancel out. So it will give you sin of theta divided by cos of theta negative. So this will give you minus of tan of theta. Now since you had already used that x equal to a cos q theta, y equal to a sin q theta, you have to put back there in the tan theta. So tan theta is nothing but y by x ka source and in the negative. So that means we had find out y by x power 1 by 3 negative, right? So that is your answer. The final answer is in the terms of x and y, not in theta. Similarly, there is one example, a p power x, and taking the both sides logarithm first and then find out the differentiation. We will find out dy by dx is nothing ax log of a. So, and similarly you have a dy dx where y equal to sine of log x, then y equal to sine log x, and take the dy by dx as equal to what? Sine, that means cos, and log x is equal to 1 by x. So cos of log x by x, and so on. So there are several other examples given for you, and the solution is also provided. You will just go through it and you will find out that all those using the same step, that taking the both side differentiation, simplifying the terms and using the chain rule, you will get the answer very easily. So here is the end of the third lecture. So thank you so much.